A body of mass m kg collides elastically with another body at rest and then continues to move in the original direction with 1/2 of its original speed. What is the mass of the target body? Okay, so m1 mass is m over here, m2 mass is unknown, let it be as it is. Okay, let the first mass be moving at a velocity u. Okay, and the final velocity of the first mass is equal to u by 2. Okay, it is a perfectly elastic collision, so for elastic collision v2 minus v1 is equal to u1 minus u2. Okay, is equal to u1 minus u2. Okay, so over here, so let this be the first equation. Okay, we have to find out the mass of the second body. Okay, we will use the law of conservation of momentum. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, plus m2 v2. So now I will shift the v1 on the left hand side. So m1 u minus m1 v1, v1 over here is equal to u by 2. So m1 u divided by 2 is equal to m2, I will take it as common, v2 minus u2. Okay, I will take it as common, v2 minus u2. So it will be equal to m, it will be equal to mu divided by 2 is equal to m2. Okay, and v2 minus u2. Okay, v2 minus u2 over here. Now understand that final velocity, the initial velocity of the particle over here, it was initially at rest. So I can say that u2 is equal to 0. Okay, I can say that u2 is equal to 0. So when u2 is equal to 0, v2 will simply be equal to u1 plus v1. Okay, it will be equal to u1 plus v1, and v1 over here is equal to u1 by 2. Okay, it is equal to u1 divided by 2. So when I substitute the values, okay, mu divided by 2 will be equal to 3m2 divided by 2. Okay, into u. Okay, u and u will get cancelled out. This is m2. Okay, this is the m2. Okay, so it will be equal to u and u will get cancelled out. Okay, and the 2 and 2 will get cancelled out. So I can say that m2 over here will be equal to m divided by 3. Okay, it will be equal to m divided by 3, which is option number C.